All right, this is the second video. That I said I would make, again, for you to use to check your answers on the similar triangles and the indirect measurements packet. Number 16. Got something that sort of looks like this. This side's 9, this side's 6, that's 5. It tells that angle's congruent to this angle. And this is 19.8, this is 11, this is X. I'm going to go through this fairly quickly, so you might have to stop your video if I go too fast, just to see what I did. So with this, first thing, we know that these two angles are congruent. We also know that these angles are vertical angles, so they're congruent, so that's enough to say the two triangles are similar. And then this triangle is going to have to be sort of spun around to match up to the other triangle. And when I'm setting up these proportions, I'm probably going to stay away from this 19.8 if at all possible, just because it's a decimal and try to make things easier on myself. But if I spin this top triangle around to match up to this one, the 5 matches up to the 11. So this 5 is going to match up to that 11 when it's spun around. And the 6 is going to match up to the X. We cross multiply, we get 5X equals 66. Divide by 5. Grab your calculator and you divide that by 5. And it tells you that X equals 13.2. That's our answer. So the length of this side right here in that triangle is 13.2. Number 17, Mr. Smith is having some photos enlarged for his studio. He wants to enlarge a photo that is 5 by 7, so we're starting off with a rectangle here. It's 5 by 7. That's the normal picture size. And then he wants to enlarge it, and he wants to enlarge it 3 times bigger. Well, that means our scale factor is 3, because we're making it 3 times bigger. So all you're doing with that scale factor is multiplying everything by that number. That's like saying 3 over 1. Well, 3 times 5 is 15, so that means the new picture is going to be 15 inches wide. And then 3 times 7 is 21, so the length of the new picture is going to be 21 inches. A couple different ways we could do this. We could just find the area and compare them. This one we know the area is 35, that's pretty easy. This one I'd have to get my calculator out to figure out that area. But we also had that theorem that about the areas that we can use to figure out the area of it, and that's what I'm going to do here. First thing I do is I just pick a side and match it up with another side. So 5 compares to 15. With this theorem, remember you've got to square each of these. And then the other one's going to be this area compared to this area that we don't know. So 35 compared to, I'm just going to leave that as A. 5 squared is 25. Ignore that. And then grab your calculator and do 15 squared. That's 225. And that's going to equal 35 over A. We could reduce this down to make it easier. This one right here to make it easier to do the multiplication, and I might go ahead and do that if I know a 25 is like a quarter, and then $2.25 there are 9 quarters, so that'd be 1 over 9 equals 35 over A. We cross multiply here, we get 1A. All I did was I took this, and you could stick it into your calculator and do it using the ABC button, and reduced it down to 1 over 9, and it just makes my multiplying easier, so I don't have to do as much with my calculator. Going this way, grab your calculator. 9 times 35 gives you 315. That means the area here is 315, but that's not our answer. They ask us how many times bigger is this area than this. Well, all I'm going to do to figure out how many times bigger it is take the 315 and divide this area by this area, and that's going to tell me how many times bigger 315 is in 35. So 315 divided by 35, and I get 9. So it's 9 times bigger. So the new picture, the area of the new picture is going to be 9 times bigger than the original picture. Number 18, they say, what is the length of BC? I'm not even going to write and draw these pictures. I'm just going to set up the proportion. They give you the way they're matched up there, and it looks like they're matched up. Looks like the 8's going to match up to 6. And then BC is the bottom of the bottom triangle. So that's going to be our X. Well, that matches up to 12. So 12 matches up to X. And if I draw them over here just real quickly, just make sure that you can see it. This is 8. This is 10. This is 12. This is 6. And we're trying to find this side right here, so that's what I'm going to let be X. So I matched up the 8 to the 6, and I matched up the 12 to the X. Cross multiply, get 8X equals, multiply this way, you get 72. Divide both sides by 8, you end up with X. X equals 9. 19. They give us pictures of a Statue of Liberty there. Tell us this is 75. Looks like we're doing a shadow problem, doing the indirect measurements. That's 75. We're trying to figure out how tall the Statue of Liberty is. You got some person standing down here. They're 6 foot tall, and their shadow is 3 feet. And we're just going to set up a proportion. Person's height compares to the statue's height. Person's shadow compared to the statue's shadow. We cross multiply, and again, it doesn't matter which cross multiplication you do first. This is 3x. 6 times 75, grab your calculator. You end up with 450. Divide both sides by 3. End up with X equals 450 divided by 3 is 150, and that's the height of the statue that we're looking at. Well, then the statue, it was all our units were in feet, so it's 150 feet tall. Number 20, same idea, only this time we know the height of the tree. I'm not sure how you would know the height of the tree and not the height of the person, but that's the way they got it this time. So we're going to set it up. Ignore that. I start writing quick, then it wants to jump like that. So the height of the tree compared to the height of the person. The shadow of the tree compared to the shadow of the person. Cross multiply, we get 25H equals, cross multiply this way, you get 150. Divide both sides by 25. Ignore all that. The 25's cancel out, and you're left with H. This is 150, not 180. All right, so if I just think how many quarters are in $1.50, that'd be 6. So when we divide that, it comes out to be 6. That means the person is 6 feet tall. Number 21. Same idea. You got the height of the person, that's 6. The height of the building is H. The shadow of the person is 13. The shadow of the building is 39. Again, this is one of them that if I look at this, I see that 39 is 3 times as big as 13. So that means this bottom number over here should be 3 times as big. So that would mean that the H, 3 times 6 is 18. The height of the building is 18 feet. If that confused you, then you cross multiply and you get 13H equals, we cross multiply this way and you get 6 times 39, which is 234. And then you divide both sides by 13. And when you divide that by 13, you end up with 18. Same answer. So some of them, if you can see it just by looking at it, then do it. 22. We got the height of the person is 3 meters. And I don't know if you understand that or not, but if a person's 3 meters tall, that means they're about 9 feet tall. Be the tallest person to ever live. So this is probably not a real great problem because it's sort of not factual. But the height of the person is 3. The height of the tree we don't know, so that's our H. The shadow of the person is 4. The shadow of the tree is 36. We cross multiply and we get 4H equals 3 times 36 is 108. Divide by 4. You end up with H equals 27. So the height of the tree is about 27 feet. Number 23. Basketball is 7'2". At 7'2". Margot Didek is one of the tallest women to ever play professional basketball. Her coach, Carolyn Peck, is 6'4" tall. If Miss Peck cast a shadow 4 feet long, how long would Miss Didek's shadow be? Round your answer to the nearest 10. I don't want to round your answer to the nearest 10th. That's sort of stupid when you're dealing with feet and inches because it doesn't make any sense. So we're going to work this out and I'll show you how to do it. So you got one person 7 foot. That little mark means feet. Those 2 little marks mean inches. And their shadow, we don't know. That's what we're looking for. And then the other person is 6 feet 4 inches. So 6 feet 4 inches. And we know that their shadow is 4 feet long. The best way to do this probably is to change everything into inches and then deal with it that way so that we can make sure our answer comes out exact. So if I wanted to change this into inches, I take 7 times 12. That gives me 84. And then I add on these extra 2 inches. So that's 86. So the Didek lady is 86 inches tall. And her shadow, we still don't know. Over here, I take 6 times 12. That gives me 72. And then I add on the extra 4 inches. That's 76. So the Peck lady is 76 inches tall. And her shadow is 4 feet. Now we can set up a proportion and solve it. And it comes, we set up 86 compares to 76. Ignore that. The same as X compares to 4. We cross multiply here, we get 76X equals 4 times 86 is 344. Divide both sides by 76. That's not going to come out even, but it goes in there. We're going to say it's 4.526. Now what we can do with that, this is our feet. So this person's shadow is going to be 4 feet, which is 1 mark. This decimal part, we take it times 12, and that's going to tell us how many inches are in that decimal part. So if you just take your calculator and you do 0.526 times 12, and it comes out to be something about 6.312. So it's about 4 feet, and we'll just say that part right there is the inches. It's about 4 feet, 6 inches. And this part is gonna be like your fraction part of an inch. So we could say it's a little less than 4 feet. If it was 6.5, it'd be an inch or 6.5 inches, but it's a little less than that. So we could say something like 4 feet. We could just say 1/2 inch, and that's pretty close, but maybe we even try to be a little more precise and we go 4 feet, 6, and we can't really say 1/3 of an inch, because that's not something that's on a ruler or a yardstick or anything anyway. So we want to be just a little less than 1/2, which maybe we do something like 17/16 or 3/8 maybe. That's on a ruler. So the shadow's going to be something about like that. And I don't expect that you're going to get that precise all the time. If you just divided this and you wrote this answer down, I would probably accept that. It's about 4.526 feet, but that's not a good answer because we're dealing with feet and inches, and they use fractions instead of the metric system where you just use decimals. Next one, number 24. They give us a picture, it looks like this, and I'm just going to draw a part of it here. It says, how deep is the water? 62 meters from the shore. It gives you this, and they tell us this is 3. They tell us that this whole thing is 62, and this is in meters. And they tell us that this is D, that's what we're looking for. And they tell us that this is 5. And what we have here is we have 2 triangles. We have this small triangle and we have this big triangle. Well, we know that these two are parallel to each other because you're just going straight down to the bottom of the lake. So you're going to make them parallel. So that means that this angle and this angle are going to be congruent, and it means that this angle is going to be congruent to this angle, so the 2 triangles are similar. If I split off the little triangle, I split off the big triangle and look at them. This side in the little triangle is 3, this side's 5. In the big triangle, this side is 62, and this side is D, and we're just going to set up a proportion from that, match them up. So 3 matches up to the 62, and the 5 matches up to the D, the depth that we're looking for. We cross multiply, we get 3D equals, cross multiply this way, you get 310, divide by 3. Now this one's in meters, so when we divide this, 310 divided by 3, and it comes out 103.3 repeating. Since it's in meters, it's all right to have that decimal because the metric system uses decimals. So we're saying about 103.33 meters. Number 25. How tall is the building? I'm just going to set this one up real quick. So we got, I don't know, it looks like a newsstand or something. Newsstand's height is 50. The height of the building is H. And the shadow of the newsstand is 12.5. Match it up with the shadow of the building, which is 50. We cross multiply, we get 12.5 times H equals, going this other direction, we get 2,500. Divide both sides by 12.5. Ignore that. These cancel out. You're left with H. That's going to be the height of the building. You grab your calculator. 2,500 divided by 12.5, and you get 200. And we're in feet this time, so that's telling us that the building is 200 feet tall. And that's a sensible answer. Not if you live in Preble County, because there's not many buildings in Preble County that are 200 feet tall. But in a bigger city, plenty of buildings that are 200 feet tall. Next one, they give us a picture, it looks something like this, 26. They tell us that this angle's got 2 marks on it, this angle down here's got 2 marks on it, this angle's got 1 mark on it, this one's got 1. That's supposed to be a 1 mark. Both these got 3 on it. I'm not even gonna put that on there because that's enough to say that the 2 triangles are similar. This is 8, this is D, that's what we're looking for. This is 5, this is 4. We're gonna have to spin this triangle around to get it to match up to that one. The 8 is gonna match up to the 4. The D is gonna match up to the 5. So the D matches up to the 5, the 8 matches up to the 4. This is another one of those that if you look at this, the top here is twice as big as this bottom, so the top over here should be twice as big here. So just from that, D is going to be 10, and that's meters. So that's that distance is 10 meters. If you want to do, if you do out the multiplication, that's 4D equals 40. That's an equal sign. And you could solve it there and figure out D is 10. 27. We got a tree and looks like a dog or something. Just going to set up the proportion. Height of the dog is 0.45 meters. Height of the tree we don't know, that's H. Shadow of the dog is 0.3 meters. And shadow of the tree is 2.2 meters. It's hard for me to read. Cross multiply, get 0.3 times H equals, we cross multiply this way, grab your calculator, 0.45 times 2.2, you get 0.99. Divide both sides by 0.3. Try to remember that when you divide by something like 0.3, your number's actually going to get bigger even though you're dividing. So 0.99 divided by 0.3, and we end up with 3.3, and that was in meters. So the height of that tree is about 3.3 meters. It's a little more than 10 feet, 11, 12 feet, somewhere around there. Next one. About how long is the creek that goes, about how long is the log that goes across the creek? They give us a picture, it looks like this. And this is our log out here, that's what we're looking for, so that's going to be our X. They tell us this is 9, they tell us this is 12, they tell us this is 8, and they tell us that this angle is congruent to this angle, and they also tell us that these 2 angles are congruent, but we also know that this angle is congruent to this angle because they're vertical angles. That means we're going to have to like spin this triangle around to get it to match up. So the 8 is going to match up to the X, and the 12 is going to match up to the 9. We cross multiply, we get 12x equals, multiply this way, 8 times 9 is 72. Divide by 12 on both sides, you end up with x equals 6. So that log is about 6 meters long. Number 29. Give us a picture, it looks something like this. They tell us that this is 12 meters, this is 8 meters, this is 25 meters, and this is X. That's X. And they tell us that, again, they tell us this angle is congruent to this angle, and we know that these angles are congruent to each other because they're vertical. They also tell us that these 2 angles are congruent, but what we're going to do is we're going to spin this triangle around to get it to match up. We set up our proportion. So the 8 is gonna match up to the 25, and the 12 is gonna match up to the X. Cross multiply, you get 8X. Cross multiply this way, 12 times 25. If you got 12 quarters, then you got $3 or 300 pennies. Divide both sides by 8. And you end up with X equals 37.5. And I believe our units again were meters. So 37.5 meters is this length right here. Number 30. Says a map has a scale of 2 inches to 6 miles. And it looks like this is a little different. So they're telling you the scale factor for every 2 inches on the map, it's six miles in real life. If Clayton and Centerville are 10 inches apart, so we're looking on this map, and you got Clayton here, you got Centerville here, and this distance is 10 inches on the map. They want to know how far are they, the real cities apart. So all we're doing, this is our first ratio. And again, this is inches, this is miles. We really don't want to change miles into inches to try to get them to match up. As long as everything on the map is in inches and everything in real life is in miles, it's going to be fine. So we do 2 on the map, 2 inches on the map, 2 inches on the map, compares to 6 miles in the real world, same as 10 inches on the map, compares to X. And when we get X, since this is in inches, this is in inches, this is in miles, this is in miles. So when we solve this, our X here is going to be our answer in miles. So we got 2 times X, and we don't have to change them all. Set up. Cross multiply this way, that's 60. Divide by 2, divide by 2. You end up with X equals 30. And remember, this is in the real world, so it's the 2 cities are 30 miles apart. Next one, they give us a picture. It looks like this. First thing I'm going to do is I'm going to separate. We have this triangle, and we know that that triangle is similar to the big triangle. So we got the little triangle and the big triangle. And make sure that you do everything right. In the big triangle, this side's 9. They tell us that this whole bottom side here is 15. Small triangle, they tell us that that part's 7, and that's H. We're trying to find H there. So we're going to set up this 9 is going to compare to the H. Same as 15 compares to 7. We cross multiply, we get 15H equals 63. Divide both sides by 15. And if I grab my calculator, 63 divided by 15 comes out to be 4.2. I would accept that answer. That's an alright answer, but it's in feet. So if we wanted, what we could do here is we know that that's 4 feet. And if we wanted to figure out the inches, we take that 0.2 times 12. 0.2 times 12. And we come out with 2.4. So it's not quite half. So we're just going to say that it's about 2, and we'll say a half because the 0.5 would be a half. So we'll say it's about 2.5 inches, 4 feet, 2.5 inches. Again, I would accept this answer, but this answer here is a little more precise, or it's a little better. I shouldn't say more precise. It's better because it's feet and inches. Number 32, find the distance between Riverside and Milton. If they're 12 centimeters apart on a map and the scale of the map is 4 centimeters to 21 kilometers, so for every 4 centimeters on the map, it's 21 kilometers in the real world. Again, same idea. 4 compares to 21. This is centimeters, this is kilometers. And we just have to make sure that over here is centimeters and down here is kilometers. They're 12 centimeters apart on the map, so that's got to go on top. And our x is on bottom. We cross multiply, we get 4x equals, you cross multiply this way. Grab your calculator, 12 or 21 times 12, and it gives you 252. And you divide that by 4. X equals 63. Remember, that's our x, so our units are kilometers. So the two cities are 63 kilometers apart in the real world. 33, a model house is 12 centimeters wide. If it was built with a scale of 3 centimeters to 4 meters, so 3 centimeters colon 4 meters. Again, just another way to write a proportion. So we're saying for in the model, for every 3 centimeters in the model, there's 4 meters in the real house. Then how wide is the real house? So we got 3 compares to 4, and they said that the model was 12 centimeters wide. So centimeters is here, this is meters. So the 12 centimeters has to go on top over here, and the meters we don't know, so I'm just going to make it m. We cross multiply, we get 3m equals 48. Divide by 3, divide by 3, and you get that the house is about 16 meters wide. So it's about 16 meters wide. Number 34, a model house has a scale of 1 inch to 2 feet, 1 inch to 2 feet. Again, these are all just written. Instead of being written as fractions, they're using that colon. Don't make them harder than they actually are. The real house is 26 feet wide. How wide is the model house? So we're going to say 1 inch compares to 2 feet. And they said the real house is 26 feet wide. So then that has to go on the bottom. And we're trying to figure out what the model house is. So we don't know that, so that's going to be our x. We cross multiply, we get 2 times x. Cross multiply this way, you get 26. Main thing here is making sure you're setting it up right. Feet, feet, inches, inches. So we know our answer is going to be in inches. Divide by 2, x equals 13 inches. So the model would be 13 inches wide. 35, not going to draw the building and the person, but it looks like they use shadow method 2 there. You got your building and its shadow, then you got your person standing here and their shadow, and we're just comparing those two. So what I'd probably do is I'd separate the 2 triangles. The little triangle is the person's triangle, and it says the person is 4 feet 6 inches tall, and the person's shadow is 6 feet. Then for the building's triangle, building's height is x, and the building's shadow, you got to be careful here because this part's 28, this part's 6, but this is the whole shadow all the way, so we got to take 28 plus 6, so the whole shadow is 34. Then we're going to set up our proportion. Now with this, we could change this into inches, but then we need to change this one into inches, and I probably don't really want to do that. The easiest thing, if this is 6 feet or 6 inches, then 6 out of 12 is a half a foot, which is the same as 0.5. So we can just change this into 4.5, and then we're gonna compare that to our X, and the 6 gets matched up with 34. Cross multiply, we get 6x equals, cross multiply this way, grab your calculator, 34 times 4.5, you end up with 153. We're going to divide this by 6, these cancel out, so grab your calculator, 153 divided by 6, and I come out with 25.5. Our answer would be in, this was feet, so that our answer would be in feet. So I would accept that answer. Maybe a better answer would be 25 feet. And since this is 0.5 right here, 25, half of a foot is 6 inches, so 25 feet, 6 inches. That might be the better answer for number 35. But I would accept this one or that one.